Now, we call y equals x squared. Everyone's attention here. Y equals x squared, that's called the parent function of quadratic. Which means this is where all the other functions come from. Okay? So this is called the parent. So this is the origin. Okay? This is the origin function. Any other function is a transformation of this one. Okay? So parent function, x squared, and then anything that you do to that x squared is going to be transforming that x squared. It's going to be moving it up, down, left, right, flipping it. Okay? This is your original, and then you're doing the transformation to that original. Okay? So let's see what that original function looks like. So I'm going to graph it. I'm going to go up by 2. So I have -4, 16, -3, 9, -2, 4. You guys know where I'm getting these points from?
No. From the table, no?
From the table, that's right. So -4, 16, right? -3, 9. So -3, 9. -3 is the x value, 9 is the y value. Are we okay with that?
I get the negative for 16, but after for the whole line, I don't know where you get everything from for the whole line.
Is it negative on the left
Sorry,
side?
just 1 second. What was your question again?
For the 16, the first one I understand. The
So it's -4,
I know it's 16.
16, yeah.
Negative
-3, 9. 9 is right here in the middle between 8 and 10.
Okay, you brought everything in the bottom down here after you count it up, right?
Yeah, because that's the x and that's the y.
Okay.
Okay? And -2, 4. -2, 4. -1, 1. So it's right here. 0, 0. It's at the origin where both the x and y meet. 1, 1. 2, 4, 3, 9, and 4, 6. If I join these points, I'm sorry, it just doesn't work properly here on that board. This is how the graph looks like. The parabola opens up. Yes?
So opens up.
Sorry? Opens up. Okay? So this is how your parent function of quadratic looks like. Study this parent function. We're going to look at its features. Remember, the features are the x-intercept, the y-intercept, the vertex, the axis of symmetry. and the optimal value. Y equals x squared is one of the special, obviously, right? Because it's a parent function. Can you guys locate the vertex for me? 0, 0, right? 0, 0, it's right there at the origin. It's right here, that's your vertex. Right? It's at the origin, which is 0, 0. So let's write that. The vertex is 0, 0, and is also known as the origin. It is a turning point, but it's because the location of it is at the origin. Okay, that's what they want. What's the optimum value? It's a 0, right? And it's a minimum or maximum? Minimum. Okay? So the optimal value is y equals 0. Remember, it's not only a 0, you have to assign that y with it. Otherwise, you're going to lose half of the mark. Okay? So the optimal value is y equals 0, and it's a minimum because the parabola opens up.
Whereas if it was the opposite, it would be max.
That's right. Now, we know that the optimal value is 0. What's your axis of symmetry?
Is it 0?
It is. Remember that the vertex, okay, attention here please. Your vertex, this is your axis of symmetry. Like it just needs you to understand that, right? And this is the optimal value. If you know what your vertex is, you already know the answers for the other two. Because they're right there. Okay? So the axis of symmetry is, well, how do I write it? Do I just write 0? X equals 0, right? Remember, it's also, it's right here, right? It passes through this, right? That's the axis of symmetry. So the graph is symmetrical about the y-axis. You see how the axis of symmetry is overlapping with the y-axis, right? This is special case. This is the special case of y equals x squared. Okay? It doesn't always happen that way. It's only for that special parent function. How many zeros does this graph have? 1. There's either 1, 2, or nothing, right? In this case, it's 1. It's right here, right? What is it? 0. 0, 0. So the zeros of the relation are, you can write as a point, or you can write it as x-intercept equals 0. Okay? You don't have to write both of them. I'm just showing you both so you guys have a choice. Okay. Once you're done copying this, I'm going to teach you a very, very, very important if you want a trick to graphing quadratic. Okay? So
to creating it.
To graphing it. Okay? Are you guys ready for me? Okay. Where's my vertex again? 0, 0. So I'm starting at the vertex. And then I want to draw it to my next point.
One, what is it? One, yeah, I know it.
You know it?
Yeah, the little box thing.
do you know it?
I'm a veteran.
Okay, so I'm starting at the vertex. Okay, so start at the vertex. If I want to get to the next point, which is right here, okay, how much do I go up by and over? I'm going from 0 to 1. How much do I go up by? 1. Right? Go up 1. Right? Now, if I want to go from this point to this point, how much do I need to go up by?
4.
I'm going from 1 to 4. How much is that? 3. So I'm going up 3. Okay? It's always over 1. So this is up 3. This is up 1. Now, if I want to go over from this point to this point, how much am I going up by?
4.
So I'm going from 4 to 9. 4 to 9. 5. Okay. It's a step pattern. Okay? It's a step pattern and a step pattern called 1, 3, 5. Guess why? Because from the vertex, to get to the next point, you're going to go up 1 over 1. Then after that, you're going to have to go up 3 over 1. Then after that, you're going to go up 5 over 1. Okay? This pattern is going to be true for all quadratics, but it's going to be multiplied by that a value, that special a value. Okay? So a, 1, 3, 5 is my step pattern. Okay? We're going to talk about a in a bit. Okay? But I want you to remember that step pattern. You have to memorize it, you have to put it in the head, where I'm going to start at the vertex. I'm going to go up 1 over 1. And then to reach my other point, I'm going to go up 3 over 1. Then I'm going to go up 5 over 1. Okay? So if you go, if I look at this, so start at the vertex, go right 1, up 1, plot a point, go right 1, up 3, plot a point, go right 1, up 5, plot a point. These points are located on the right side of the y-axis. You can do exactly the same thing to the left side because of the symmetry. Okay? So if I look at the left side, right, I'm going to go up 1 to the left 1, up 3 to the left 1, up 5 to the left 1. Okay? Because of that beautiful symmetry that we have. Okay? So, if you know what your vertex is, your life is easy. Graphic. Starts from a vertex, do your step. Okay? We'll do more examples. Don't worry, it's not gonna be, I'm not gonna throw you under the bus and tell you to go graphic. Okay? We're still brand new in this. Okay. Can I move to the next slide? I want to see what I have there, and I want to see if I want to stop. I don't think I can bombard you with more information because I feel like no matter what I teach you right now, it's gonna go. You know.